Alright, this is our second day of factoring, or the second video of factoring, maybe I should say. And we're going to start by factoring something a little bit more complicated than yesterday. And one thing that you can notice, in each of these three terms, we can take something out. And there's p to the third in all three of them. So we want to start by taking out that, leaving 6p squared plus p minus 1. Now we can't factor that left-hand side, p to the third, any longer, but we could see if we can factor this. Sometimes it can be factored and sometimes it can't. Now, to see if it can be factored, we could just do the guess and check method, or we can split the middle term. I like to split the middle term because it's easier to teach. The guess and check method, to teach it, I just pretty much just show you the answer. So that's not an easy method to learn. Alright, so if we look at this, what two numbers multiply to -6 and add up to 1? Hopefully you think of -3 and 2. So we can split that middle term being minus 3p plus 2p minus 1. Now, this gets a little weird with this p to the third on the outside, but it'll still work out. Out of these first two, I can take out a 3p, leaving over p 2p minus 1. On these last two, there's nothing I can take out, so that's a 2p minus 1. Now if I factor this 2p minus 1 out of the equation, so I have p to the third, 2p minus 1, what's left over is just this 3p and the plus 1. So this factors down to p to the third times 2p minus 1 times 3p plus 1. Alright, try this one, see how far you get. Hopefully you're finished with the problem. What I can see is there's a 3w cubed that we can take out of each term, leaving a 2x squared minus x minus 15. Now, again, there's two methods for this. You can either guess and check. Since the last one I split the middle term, this one I'll guess and check. This is 2x and x. 15 can either be 1 and 15, 15 and 1, 3 and 5, and 5 and 3. So those are the four options that we can have for these last two places. Let's put in 1 and 15 first. Now if I multiply it out, it'll be 30 and 1. Can I add and subtract 30 and 1 to get down to -1? That answer is no, so I take that out. So now if I do 15 and 1, that'll be a 2x plus 15x, or minus 15x, and that won't get us down to x, so we'll get rid of that. Now let's do a 3 and 5. This would be 10 and 3. That won't get me down to x. What if we do the last one, which is 5 and 3? That will be 6, 5. So that will get us down to -1 if I have a minus 6x plus 5. So 3w cubed, 2x plus 5, x minus 3. Alright, moving on. This one is a little tricky because at first it's got a v to the fourth, but hopefully you can recognize that this is the difference of two squares, like you learned in the previous day's lesson. So we can take this down to 4v squared plus 1, 4v squared minus 1. Now this first term, we cannot factor this any longer, because it's not the difference of two squares, it's the sum of two squares. But this is the difference of two squares, so we can factor that down even further. So this first one remains the same. The second one becomes 2v plus 1, 2v minus 1. All right, now on this problem, we want to solve this equation by factoring. We have x squared plus 8x plus 15 is equal to 0. So what we want to do is first factor this and then figure out what values of x will work for this equation to equal 0. Well, there's one thing that we have to go back and remember first. If 3x equals 0, what will x have to be? Hopefully you're saying 0, because 3 times 0 is 0. What if we have x times y equals 0? What do we know that x has to equal? Well, we know either x is 0 or y is 0. So now we're going to use that to work on this. So if I factor this first equation, what two numbers multiply to 15 and add up to 8? Hopefully you know that that's 5 and 3. But now what we do is we take each of these equations and we set them equal to 0, because x plus 5 equals 0 and x plus 3 equals 0. So now we subtract 5 on both sides, so we have x equals negative 5. If I subtract 3 on both sides, x will equal negative 3. And so we have our two values for x. Now if we put either of those in for x, we better get down to 0. Let's try this. Negative 5 squared is going to be 25. Negative 5 times 8 is going to be minus 40. So if we add these together, we get negative 15. Negative 15 plus 15 will get us to 0. We can do the same thing with negative 3. Negative 3 squared is 9. If we add negative 24, that will get me down to negative 15. Add another 15, and we'll get to 0. So these are the only two values where that will be true. Let's try this next one. If you can do this, pause the video and see if you get the correct answer. Now what I would do here is first I would factor out a 3x, leaving over x squared minus 16. Now x squared minus 16 is a difference of two squares, so that can be x plus 4, x minus 4. Now instead of two equations, we're going to have three equations, where 3x is going to equal 0, x plus 4 is going to equal 0, and x minus 4 is going to equal 0. Well, if 3x equals 0, we divide by 3, and x is just 0. If x plus 4 equals 0, we subtract 4 on both sides, and x equals negative 4. X minus 4 equals 0, we add 4 to both sides, so x is equal to 4. So this problem has three different solutions. All right. Try this one on, pause the video, try this one on your own and see how far you get. All right, now this is a situation where I would much rather use splitting the middle term than factoring, because there's 4 different ways we can write the first two numbers, 1 and 6, 2 and 3, 6 and 1, and 3 and 2. And is that 6 different factors of 12? 1 and 12, 2 and 6, 3 and 4, and then 4 and 3, 6 and 2, 12 and 1. So if we multiplied 4 times 6, there would be 24 different possibilities. And that's a lot of guessing and checking. It's possible you can get it on your first try, but I would much rather have a systematic method than doing guessing and checking many times. So what I do is multiply these two numbers, get negative 72. And now what multiplies to negative 72 but adds up to negative 1? That answer is negative 9 plus 8. So I'm going to split this middle term up into 6s squared minus 9s plus 8s minus 12 equals 0. If I divide this down the middle, I'd take 3s out, leaving 2s minus 3. Over here, I would take out a 4, leaving 2s minus 3. Now I can factor out a 2s minus 3 out of this equation. And when I do, these two go to the outside, leaving 3s plus 4. Now we need to solve this. So we make two different equations. 2s minus 3 equals 0, and 4s plus 4 equals 0. Now it's just basic algebra. I shouldn't say that. Every time I say basic algebra, that's when I make a mistake. But now we divide by 2, and s is going to be 3/2. Up here, I subtract 4. 3s is equal to negative 4. Divide by 3, and s is equal to negative 4/3. So these are the two values for s, 1.5 and negative 4/3. All right, now solve this one by factoring. So this one we're not actually looking for equals at 0. Hopefully you can see that this is the difference of two squares, so it'll be 3n plus 2, 3n minus 2. If you can't find that that's the difference between two squares, some people spend a lot of time on problems like that. All right, I think from here on out, we've already gone through them, so hopefully that's all you need to do. Look at the extra supplements to see if you need more practice. Good luck.